All right, so let's refine this a bit. So epsilon can be a lot bigger um, for this is a very hackish epsilon right here. Right there, hackish epsilon. Right, let's zoom in there. So that's a pretty hackish epsilon. We should probably use something bigger. I'm not like I don't want to think too hard about it. So if we're looking at this, where are we? Actually, I gotta put this down here so you can see it. Actually, no, I can put it over here, can't I? Yeah. So if we're looking at epsilon, there's this CS357 course that I'm looking at that is kind of like saying that for our single precision epsilon, what is it? 2 to the power of negative 23, and I guess it's roughly this. So 2 to the power of negative 23, 2 to the power of 0. Machine epsilon is defined as the distance gap between 1 and the next largest floating point number. Okay. So epsilon m. So I'm gonna guess if so 23 places. So is this like 23 zeros then? 1, 2, 3, 4, 5. Oh god, that's gonna take forever. Let's just copy this really quick and see how many zeros there are here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, 23, right? So, if 23 zeros, I guess we could probably do 20 zeros and we'd still be pretty good. We'd be a lot better than this, right? So, let's just give that a shot. So, we're gonna just throw in a whole bunch of zeros there, and then we're going to try to get it to about 20 and make sure that we count them. So we'll do like this, and then a 0 for the 10, and then we'll take this pattern and we'll duplicate it, and then we have a problem because epsilon, let's do E for epsilon, that way we can have a little bit more room here. And okay, so we have enough room. Let's do EPS for epsilon, right? And we'll undefine it right after we use it, so it's not a problem. So 0 point. I'm just this is just me kind of measuring out the places in the code so that I can kind of see that it's correct. So this is the 10 is there, and then 20 is there. So you know what? That looks good enough to me for epsilon. Now the question is that going to work? Are we going to screw things up doing that, or is that good? Is that going to still render? So let's just take that, and we're going to paste that into Shader Toy, and we're going to see if that works. And we have screwed something up again. How the fuck do we screw things up so easily? So, because epsilon. So we've changed that, so we got to do this. Okay, and then we can actually, we got our semicolons back aligned in the same spot, so that's cool. Okay, so let's take that and let's see if that works. Okay, it's green. Now, let's make sure that everything still looks correct, and oh boy, that sure doesn't look correct, does it? It looks like we broke stuff. So, is this just too small of a number, or maybe our math, we have to think about what our math is like? I don't know. So we could try going to this many digits and see how that works. So let's try that out, see what that looks like. you know, we're just hacking around and seeing if we can get a smaller value and see how small we can get for everything to still look good. And, oh my god, it still looks like crap. So, well, let's try, okay, so, I believe the epsilon value we used before was like 0, was this, right? I'm pretty sure it was, so let me check the previous version of this. Control F and my 0.000 something or other, or whatever, let's find it. 3 zeros and then a 1. Okay, so if we have 3 zeros and a 1, that was back to where it was working before. That's kind of concerning that it's not, that it's kind of like this hackish value, and it's not exactly what I thought it would be. So, what could it be? Could it be something like, one, I'm thinking that it might be epsilon for each axis, and maybe the epsilon should be, I'm thinking that maybe there should be epsilon x, y, and z. So if we're going to refine this and get it proper, I think that possibly the epsilon value isn't like some arbitrarily small value. It's actually something that's kind of hinged more on the reality of how we're doing this. So I have a hunch, this is just a hunch, that our epsilon value is something like 1.0 divided by the NPX, number of pixels on the X, and float32, number of pixels on the X for a single tile within a for a single tile, right? So our voxel is this number of pixels wide. So I'm thinking that the epsilon value that we need is actually this for the X, and then the respective thing for the Y and Z. So 1.0 divided by float32, and then NP, Y, and Z. So that is just a guess. I could be full of shit right now. So X, Y, and Z. And we're gonna just take a guess that these are the actual epsilon values rather than arbitrarily throwing in a magic number. And it's just a guess. Like, I could be totally wrong here, but I think that might actually be the real value that we're looking for. So let's run that and kind of see, does that look correct or does that look worse? And it looks fucking worse. So we have 1 divided by the number of pixels on the X. Number of pixels X, number of pixels Y, number of pixels Z. Okay, so that definitely looks worse. Let's make sure that NPX is what we think it is. Yeah, that's that. So yeah, that's what it is. Huh. Yeah, I don't know. That's weird. So, you know, that was my best guess. I was really hoping that would give me something that would actually work. Huh. So let's just go back to the EPS epsilon value that we're kind of like hacking away at here. And so that's a no-no. This is a fuck you, you're wrong. So I don't know what the actual value should be. We could try 0.1. I don't know why that would matter. I mean, obviously it's going to be smaller, so it might just work by coincidence. Yeah, right. It's smaller, so it's just going to work by coincidence. But I do feel like that epsilon value should somehow be tied to the individual axes, and that's why I think that it should be like... well, we could do this. We could do the original 3 zeros, and then make it even smaller by dividing by the respective axes to make it consistent for the size of each. Yeah, let's just try that and see what we get there. And I feel like even if that works, that we're adding a lot of extra calculation that... Oh, and there we go. It's erroring out again. It's giving us that orange background, which tells us that there's some type of problem. So now, when it airs out, are our voxels still there? Well, our voxels are still kind of there, and actually it looks nice and symmetrical there. Let's just put back the actual values that we had, and let's run that and see if we have nice symmetry up here. Yeah, it looks all really nice on the edges. So the edges look really nice and symmetrical. If we put just the epsilon as you know... Yeah, I don't really see any difference. So I'd say that's probably good enough. I see a little jaggy right here. Nah, that's not really an issue. Okay, so I have no fucking clue why it's like... Let's just see how many zeros we can get here and see how far we can take it before it breaks down, right? So let's try to, like, just add smaller and smaller values. And even that... What the hell? So I just, like, nailed it with the 3 zeros and a... Okay, so I have no clue how the hell did I just nail it in the first try and just get it? Like, that is shocking. Like, one more zero, and we're in an error state. And I know we're in an error state because I see the background just kind of glowing orange. So, whatever it is, whatever I'm doing here, it's 3 zeros and a 1. Now we could try, I don't know, we could try 0.1. I'm just curious. Let's see what else we can mess with, because maybe that value is actually too small, and let's kind of just mess around and see what we see here. So actually, no, 0.1, I still see... horrible artifacts. There's still these horrible artifacts. Yeah, so I have no clue why that is. I have absolutely no clue why it is 0.0001 and no more zeros than that. Exactly that. That's crazy. Yeah, I'm like looking at the screen, like, let me zoom in here. Can we zoom in here? 300%. Maximize. Enhance. Okay, that didn't quite work. It is like a GLSL canvas, so that kind of makes sense that maybe zooming like that wouldn't work. Okay, let's reset that. Yeah, so that, yeah, I have no clue why that works. Gonna make a little comment here. Yeah, so we're just gonna go back down in the documentation and just say... Okay. So I have no clue why that works. So it works, but I don't know why. You know, sometimes sometimes you don't have all the answers, and it's good to document why, rather than just have a magic number. I think at least saying, I have this here, I have no clue why this works. I have no clue why exactly 3 zeros works and 4 zeros doesn't, and less doesn't work. I have no clue why this is the value that it needs to be, but that seems to work. So we're gonna we're just gonna roll with it, and yeah, we're just gonna roll with it. So yeah, we'll roll with it, and also let's add some more resolution to these voxels. Right, it seems like we've debugged this. It seems like we've fixed it, and to really prove that to ourselves, we're gonna have to change the voxel size preset. Oh, got ya. So we lost 16, 16, 16. Yeah. So let's do if 16, 16, 16 equals voxel size preset. And let's just add in back in the end. Let's just add that back in. So we'll just take all this. Right now, this is obviously very, what do you call it? This is obviously very verbose, and it's like, why would you do this? Why wouldn't you just change them one by one? Yeah, I don't know. So far, this seems to have been working nicely, so I'm just gonna stick with it, right? So the number of pixels, we're going to do 16, 16, and 16, because this is what we were using earlier. So let's try that. Let's put 16, 16, 16, and see what that looks like, right? So go over here, paste that in there, give it a run, and see what we got. And it should look awesome, I hope. Oh yeah, that's awesome. Oh yeah, that's good. That is some good stuff. It's perfect. It's like we gotta, you know, this is so good. This is so good. I need to slow down that camera. So let's go to the so somewhere we have like a dolly, and I know that we kind of like threw in different dollies for different cameras, so it's like, is this the dolly variable, or is it the other thing? I don't know. We'll put a 0 right there in here, and let's just try to see if that is the dolly variable or not. And you'll know because nothing will move, right? So if we play this, oh hey, nothing's moving. Nothing's moving, nothing's moving, nothing's moving. Okay, so that is the dolly variable. Also, let's look at this. Does this make sense? Yeah, this makes sense. So this looks like it's double the thickness because we're looking at the underside and the front-facing side, or the left side, and underside and front-facing side here. So this looks double thickness. That thickness is actually correct compared to here. Yeah, so that all looks good. So the next thing is we'll put that dolly back in, and in our cos values. So here's our coses. Let's slow that down. Let's slow it down by, I don't know, 8. So that's 4 times slower. Yeah, let's just give that a shot and see what that looks like. I just want it to go slow enough to where I can kind of like just observe the effect of that cross-section moving, and kind of comprehend it a little bit better. That is not what I want. What the hell? Oh, got ya. This was not a scalar to slow it down. This was a scalar to translate the graph to be either all positive or all negative. So we need to take I time times 0 point, and then let's say 10% speed, right? And let's do F32 SPD equals I time times 0.10, right? So let's actually make a speed variable, and then we can plug in the speed variable kind of like right here, and we can kind of make the line of code a little bit smaller, and SPD equals speed, right? Just a little note, in case you're wondering what the hell is SPD, well, now you know it's speed. So let's take a look at that and see what we have. So get that running. And, alright, so it's going nice and slow. Maybe too slow, but it's definitely slow enough to where I can observe frame by frame, like how the geometry is getting sliced by the camera as the camera comes into the geometry. And making it go slow enough, I can see if anything looks weird, if there's any artifacts, or if it all kind of like makes sense. And I would say that, yeah, the geometry here, it looks like it is all sensible and it's all like making sense. So with that, I'd say let's have some fun, because you know it took us forever to figure out all this math. Let's go into the tile map that is currently active, and let's just add some more geometry. You know, just have some fun. I think we deserve it, or not deserve it. I don't know. Deserve is a word I really don't like, just because it implies immorality, and really the universe is just cause and effect. So let's rephrase that. I want to have some fun. I want to take a break, because I've hit a good checkpoint, right? So let's look at where we have our tile map data. So we have all these different tile maps, and we got to figure out which one of these tile maps is active. And I realized that we I see why we wrote the ifs like this, to make sure that this matches that. But it's harder to identify which preset everything is associated with doing it that way. So I see a 333 here, so let's see. So this tile map preset, right? So you know what we're gonna do? We're gonna double wrap this in. So 333 equals tile map preset. And the reason why we're going to double wrap it like this is just so that it's not really necessary with the way we've done it, but this will just make it easier to identify this. Rather than having this obscure comment here, we can just identify it as this. Now, and this is kind of like a double redundancy here to make absolutely fucking sure that, you know, this is the preset we meant, right? So let's save that like that. And let's rerun that, make sure that that logic didn't actually break anything. And it looks like that logic was okay. And I see nothing but blackness, and that kind of scares me here. Let's can we reset it? Oh, there you are. There it is. Okay, so we probably need well, let's look at this. Let's create like a cube where this is the top of like a cube kind of frame. So this is the top, and then we have these is the midsection, just the legs connecting the bottom of the frame, and then we'll create the bottom part of the cube. So let's do that. Let's see what that kind of looks like. So, alright, so top of the frame, frame midsection, just the legs, and then the bottom of the frame. So just a giant cube. Let's try that. Let's see what that looks like, and see if, I don't know, let's just see what it looks like. Let's have some fun. So, give that a shot, and oh boy, oh god, oh my god, there's so much there. But now we can, so this little white part looks kind of like maybe that's wrong. I don't know. Or maybe I'm not looking at the vertex. I think that might be two vertices merged together and I don't realize it. Yep, two vertices merged together and didn't realize it. So that is pretty trippy. And that is pretty awesome. So this is like the camera kind of like slicing halfway through the geometry, and we can see the back here. There's no perspective though, right? Because we're trying to do it in perfect orthographicness. We're trying to do it perfectly orthographic. Let's add some color coding, right? So let's add, why don't we do like RGB? Just because R, G, and B is like, I don't know, it's a thing, right? So we'll do the lowest, or this is higher up on the tile map, the midsection of the tile map, and then this is the bottom Z layer. So R, G, and B. B being last. Okay, so let's just color code that and see what that looks like, and this is fun. I'm having fun. Okay. So give that a run and kind of see what that looks like. We should see kind of the same thing, except we'll see kind of like different colors kind of merging together here. So that's really interesting how in the slice plane, how the like this border between the red and the green, that's really cool. Let's like, that is pretty badass. That's badass. So you know what? Yeah, that's pretty cool. So you know what? I honestly want to. I know we've just kind of had fun right now, and we didn't really do anything different besides be like, what the hell is epsilon? But this is I think this is a good checkpoint where it just makes a very pleasing geometry here. And so, so SDF 15, no real changes. So no significant changes since SDF 14. Just had some fun and messed around with the hard-coded tile map data and camera dolly that. Okay, so we made a little. I made a little description here. So SDF 15, no significant changes since SDF 14. Just had some fun and messed around with the hard-coded tile map data and camera dolly that creates the slice plane, right? So I think that having this kind of permanently as a file in our kind of like series is good, because it looks really awesome. It's a good milestone, even though it's not anything really significantly has changed since the previous version, but it kind of shows off what the fixed version of it kind of shows off what SDF 14 can do, right? SDF 14, we fixed the rendering problems, but I think SDF 15 will just be here to kind of like show off what it is capable of. So let's take the summary up in our code. SDF 15's focus. This is more, so we're gonna throw this into, we'll throw that into SDF 16, and voxel engine work. No new changes since SDF 14. Just messed around with the hard-coded tile map, voxel map data to see what kind of awesome stuff I could do with the code we fixed during SDF 14. Okay, so we're just gonna make this note that you know, this version isn't really any changes. It's just that we've messed around with SDF 14. No new changes since SDF 14. Just messed around with the hard-coded tile map, voxel map data to see what kind of awesome stuff I could do with the code we fixed during SDF 14, right? So, you know, I think it's totally okay to like make a checkpoint like that where we didn't add any new functionality. We just experimented with what our current functionality could do, right? Because I think playing around with it, like, what if I played around with this and it didn't react how I expected, right? This is reacting how I expect it to react, so it's good to take that time to mess around once you have a fix, right? Because you have the fix, but maybe it just works with the current set of inputs, but another set of inputs doesn't work, right? So that was fun, and we didn't really do anything new, but we got somewhere, right? We got to what I would call a checkpoint. So let's take this and let's save the shader toy. So I'm gonna save SDF 15. Okay, that's saved. And actually, no, we're gonna copy paste again because I think I may have made some edits to the comments. So paste that, and then we'll run it. Okay, still runs, and then we'll save that. Okay, so that's saved there, and then we will go to Pastebin, and we're going to update the Pastebin. So www.tinyurl.com/sdf015, and that's going to take us to the Pastebin for this, and we're going to update the source code there as well. And we're going to hit edit, and we're just going to paste the new version of the code. And that looks good, so we'll just hit save changes. Okay, awesome. So now that we kind of got that, let's just create a new file with just a copy of everything we've worked on, and let's keep on going, right? So let's take this comment that was originally for SDF 15, and let's put it into here, right? So it's voxel engine work, and so this is kind of like the agenda. All right, and we have to say that this is going to be 16 now, this is going to be 16 now. We're going to blank this out till we know what these values are, because we need to set up a new shader. And 16, technically the stream name still is SDF, 15. So what we're gonna do is we're gonna stop the stream and we're gonna restart with the new name. So that's what we're gonna do. So I'm gonna stop the stream and I'll be back in a few minutes once I have everything set up.